Sanbonani Abafundi, welcome back, and today we're going to look at a couple of examples that involve simultaneous equations. And simultaneous equations often occur in maths. They occur in a whole lot of different topics. You'll see them in topics like sequences and series. You could even see them in a topic like analytical geometry and in equations, obviously. But interestingly, here in calculus, we're going to see as well. So typically, what we need to look out for in maths, when we have a situation where we are asked to find two variables, very often we need to set up two separate equations and solve them simultaneously. Okay, so let's just have a look at these examples here. So, as I said, these examples involve simultaneous equations, and let's just have a look. We're being asked to find two different variables, A and B. Right, A and B. Now, what we're given two bits of information here. We're firstly given that the point 1, 1 lies on this line. All right, so in other words, this here is a point that lies on the line. That's the first thing that we can read there. All right, and that will allow us to substitute that point in here. So the y value is 1, the x value is also 1, so it's going to be a times 1 squared plus b times 1 minus 4. Now that is an equation, but it's got two variables in it, okay? We can actually simplify it. We can add 4 to both sides. So in fact, a plus b is 5, okay? But then we also know that the gradient, and we know about gradient, the gradient of the tangent, all right? The gradient of the tangent is 7 at that point, 1, 1. Right, so how do we work out gradient? Absolutely, we're going to differentiate our function. So we're going to get dy dx is 2ax plus b. Now, we know that when x equals 1, dy dx, or y dashed, is 7. Okay, that's what that's saying. The gradient is 7. All right, so now when we put 1 in here, we're going to get 2a times 1 plus b equals 7. And now we've got a second equation. So we've got two equations, all right? And remember, there's various ways of solving simultaneous equations, but quite a cool way, if they both have the same number of a variable, is to do a process of elimination. So what I'm going to do is I'm going to write equation 1 down underneath here. And so we've got 5 equals a plus b. What we can do now, we can subtract these two equations. And if we subtract them, the b's will eliminate, okay? And we get 2a minus a, we get 1a. And 7 minus 5, we get 2. So a is 2. Then we go and substitute that value for a into either equation, all right, to get the value for b. Obviously, if a is 2, b must be 3. And we can just check that that is in fact correct, because if we go and put into equation 2, if a is 2, 2 lots of a, 2 lots of 2 is 4, plus what to give, yeah, b is 3. So there are our answers. I'm just going to highlight those answers in yellow. A is 2 and b is 3. Remember, there is another way of solving equations simultaneously, and that's by substitution. I'm going to ask you to pause the video and try question 14 and 15, and we'll go over them shortly, and when we go over them, we'll do one of those at least by substitution. Okay, so let's take a look at this one. Quite similar in that we know a point on the graph, so let's work with the point first. So let's just put that point into this equation. When y is 3, well, y is 3 when x is 2. 2 cubed is 8, so we get 8a. 2 squared is 4, so we're going to get 4b. Minus 2 plus 1, that's going to be minus 1. Okay, so what we're going to get here, this is still equation, we're going to call this equation number 1. We're going to get 4 over here equals 8a plus 4b. And in preparation for solving simultaneously, I'm actually going to divide everything through by 4 here. So 1 equals 2a plus b. And in fact, I'm going to subtract 1 from both sides. So b is actually 2a minus 1. Now I've got one equation, but it's got two variables in. Okay, now we're going to work with the derivative to find the gradient. So let's call it dy dx. And that's going to be 3ax squared plus 2bx minus 1. Okay, and when we put 2 into here, we must get 7. All right, so 2 squared is 4, so we get 12a. We're going to get 4b minus 1 equals 7. Right, so in fact we're going to get 12a plus 4b, sorry, 4b equals 8. Okay, now this one this is equation number 2. This time we're going to solve by substitution. So we're going to write out equation number 2 again. 12a plus 4 lots of b equals 8. But from equation number 1, we know that b is actually 2a minus 1. So what we've done is we've substituted this value for b in here. Right, there it is. There's b, and this is b, and so we've put it in there. Now we only have one variable, and it will be easy to solve this equation. So we're going to get 12a plus 8a. We're going to get 20a minus 4 equals 8. So we're going to get a equals 12 over 20, which is sounding a little bit unfriendly, but I'm just going to pause the video and just check that I haven't made a silly mistake. Indeed, I have made a silly mistake. Okay, b is not 2a minus 1. My apologies. b is 1 minus 2a. Right, so b is 1 minus 2a. And that is what I'm going to substitute in for b in the other equation. I was just a bit surprised that I'd made up a question with a fairly unfriendly answer. Okay, it doesn't mean it's wrong, but it just didn't look right to me. Okay, so 1 minus 2a is in fact what we're going to put in here. 1 minus 2a. Okay, so now what we're going to get, we're going to get 12a minus 8a. We actually going to get 8a. Sorry, 12a plus 4 minus 8a. We're going to get 4a plus 4 equals 8. And now we can solve for a. We're going to subtract 4 from both sides. We get 4a equals 4. A must be 1. And b will be 1 minus 2 lots of a. B will in fact be minus 1. Okay, and there's our answer. Right. Now, for number 15, it says find p and q if this function has a maximum value. Now, what shape is this graph? This graph is a parabola. Now, what do we know about the gradient? And this is a really big idea that we're just starting to understand now. But what is the gradient there? At that point, all right, 2, the x value is 2 and the maximum value is 2, the y value, maximum value is 2. At this point, we also know that the gradient is 0. When a graph turns, the gradient will be 0. This particular graph goes from a positive gradient to 0 to a negative gradient. But if we had a minimum and it turned at a minimum, it would go from a negative gradient going downhill to 0 to a positive gradient. Okay, so we can form, once again, we can form our two equations. Right, if we just put the point in, when x is 2, y is 2, remember we're going to go 2 equals, now we're going to square 2 and then make the answer negative. It's negative 4. We don't square negative 2, all right? It's the negative of 2 squared plus 2p plus q. So there's an equation. It's got two variables in it. Let's just go 6, add 4 to both sides. 6 equals 2p plus q. Okay, so that's equation number 1. Let's look at what equation number 2 is going to look like. So we're now going to work out the derivative, the gradient, dy dx equals negative 2x plus p. And we know that when x is 2, dy dx must be 0. Okay, so when we put 2 in here, we get negative 4 plus p equals 0. So in fact, we actually know that p is 4. Okay, now we're going to take that value for p and we're going to sub it in over here. So we get 6 equals 2 lots of p, that's 8, plus q. All right, so if we subtract the 8 from both sides, we get that q is negative 2. And there's our answers for p and q. Okay, right, so we're going to stop there, a fairly short lesson, and in the next lesson we're going to start with a quick recap of what we've done so far, and we'll carry on from there. Have a great day, everyone.